Welcome to our arc length lesson. Before we begin, please do a little review on the unit circle. So I want you to take out a piece of paper, draw out the bare unit circle, and then start labeling all the angles and its exact values. So for example, take out a piece of paper, draw your unit circle in like this, write out your exact value, which is 1, 0 here, and we're at 0 radians here. Then you could also do pi over 2. Your point would be at 0, 1. And then you could do pi over 6. Write the exact value here. Pi over 4. Write that exact value, point, and then pi over 3, and so on. Do it all the way around along your unit circle. You can use your notes as a reference if you forget, but you should have these memorized. After you finish that, we're going to begin our lesson on the arc length. So an arc is a portion of the circumference of a circle. So here's your circle. The arc length is just a portion, let's say from here to here, of that circumference of a circle. So the arc length is just the length of that portion of the circumference of a circle. The arc length S of a circle of radius r with central angle theta radians given by this formula here. This is how you're going to find arc length. So S represents the distance, R represents your radius of the circle, and then theta is your angle in radians. Remember that your angles have to be in radians. Don't use this formula if your angle's in degrees. It's not going to be right. So for example, one, it says determine the arc length. So our formula is S beta r. The angle that's given to us is already in radians, so 5.1, and our radius is 4. 5.1 times 4 is 20.4, so that is going to be our arc length. Here's another example. A circle with central angle 12 and radius 8. So r is equal to 8. Theta is equal to 12. So arc length is theta times r, which is 8 times 12, which is 96. Moving on to C, we're given our angle, that's pi over 6, and our radius is 7. So S is our angle pi over 6 times the radius, 7. Then our arc length is 7 pi over 6. Question D, I already said right here, our angle is not in radians. We have to do the conversion first. In order to change this to radians, I multiply that angle by pi over 180. And then put into the calculator. This gives us 3.29. Okay, so that is our angle, and then we are going to find the arc length. That's 3.29, and here it's not going to be 9. If you look at the information that's given to us, D is 9, so that means our radius is half of that. Remember, your diameter is twice the size of the radius. So 9 divided by 2 is 4.5. So to find the arc length, that's 3.29 times 4.5, which is 14.805. It's a very short lesson today, so go ahead and do that. Try it yourself, and then when you're ready, press play. So we have a circle with a central angle of 7 pi over 4 and a radius of 14. We're given the radius, we're given an angle in radians, so we can go ahead and do our calculation, which is 7 pi over 4 multiplied by 14. If you want to put this into your calculator, you can go ahead. If you don't have a calculator, you can leave it in terms of pi, and that's fine. So if we did that, we would just simplify as much as we can. So 14 divided by 4, if I divided this by 2, top and bottom, we're going to get 7. 14 divided by 2 is 7. And then 4 divided by 2 is 2, which would be 49 pi over 2. And then our last try it yourself, we can change this into radians by multiplying 277 by pi over 180. So 277 times pi divided by 180 is going to give us 4.835. And then when we calculate the arc length, we're going to have 4.835 as our angle, and our radius is half of 6.4, which is 3.2. So then our final answer for our arc length is 15.47.